Alrighty, ladies and gents, so today we're going to be talking about linear functions. Now when you think of linear functions, you're often wondering about the term f of x. Well, what is f of x? We're going to get to that. But first, some definitions. The first word is a relation. A relation is a set of ordered pairs. So in this graph, the age and height in the ordered pairs below form a relation. The domain of a relation is the set of the first coordinate of the ordered pairs. So if you take a look then, the age would be the domain. The range is the second set of coordinates. So the height would be the range. So if I wanted to find the domain and range of the ordered pairs listed for the data, the first thing I need to do is list the values in order and make sure not to repeat the values. So here's how it would work. For the domain, I would make a nice little squiggly known as a brace, and then I would write in my values in order, making sure not to repeat values since I see there are two 18s. So I'd write it down as 14, 18, 20, and 21. Then I would take my range values, again another bracket, and in order 4.25, 4.40, 4.85, 5.00, and 5.25. That's how I would list the domain and range of the ordered pairs listed for the data. Alright, so let's talk about a function itself. A variable y is a function of another variable x if each value of x corresponds to exactly one value of y. Or another way you could say it is that a function is a relation that assigns exactly one value in the range to each value in the domain. One way you can tell whether a relation is a function is to analyze the graph of the relation using a vertical line test. If any vertical line passes through more than one point of the graph, the relation is not a function. So for example, let's say you were looking at a couple graphs on a sheet of paper and you had your pencil. This is a pencil. You'd run it across the graph and you'd see that at no point does the line pass through more than one point on the graph. Here, so this, we can say, is a function. If we take a look at the next graph, as I run my pencil, whoa, it went below. Technical difficulty here. Order it. Let's send backwards. All right, here we are with our pencil. Hey. Try it again. Here we go. As we run our pencil through the graph, we can see that it is a function because at no point does the pencil touch more than two parts of the line. Here's where it's going to get here's where it's going to get a little tricky. Because as we can see, when I run the pencil through, the pencil touches 2 points on the line, right there and right there. So that tells me that it is not a function. If I keep moving it throughout, we can see wherever I place it, there's going to be more than one spot where the pencil touches and gives me two responses. So here I can see that it's not going to be a function because each value of x is giving me two values of y. So the vertical line test, your friend and mine. So we've been talking about different words like domain and range. Another thing you could think about it is in terms of input and output. So whatever the domain is the set of input values. There's a certain rule, and then the output ends up being the range, and it's the set of those output values. So sometimes you will see equations set up in the form of x and f of x, like right here. There's no need to panic about f of x. F of x just means function of x. So you can read it as f of x or function of x. That really just means, that's another way of saying y. So the output, f of x, y, these are all the same. These are all related together. They're pretty interchangeable and you will see them used. They all represent the same thing. And then the domain is your input, that's your x value, that will still remain as your x value. Now one thing to notice is that it doesn't have to be f of x. It could be g of x, it could be q of x, it could be h of p. It doesn't matter, they all represent that same kind of idea of f of x. So there's no need to panic about that. It all means the same thing, except if you see something like h of p, then that means that in this equation over here, 3x plus 4, you would see it as 3p plus 4. But it still all relates back to that same linear function that we've been working with for a long time now, y equals 3x plus 4. So here are some examples. What I want to do is evaluate f of n. Again, there's that different letter, where it equals negative 3n, f of n equals negative 3n minus 10, where n equals 6. Here's all you have to do. You take that number and you plug it into the equation and then you work it out. So if f of n equals negative 3n minus 10, then f of 6, that means a function of 6. If my input then is 6, my output's going to be negative 3 times 6 minus 10. And then we go ahead and simplify. That equals negative 18 minus 10. So f of 6 is negative 28. And that's how I would show my answer. You can go ahead and do the next one on your own. Evaluate g of x equals x squared minus 1, where g equals 2.1 to get that started. I would say g of 2.1 equals, in parentheses, 2.1 squared minus 1. Go ahead and solve that and you'll get your answer. And here's a challenge, kind of. What I want you to do is determine whether the relation is a function. So here's a list of ordered pairs. You can rewrite it as a table if you like. You can set it up as a graph if you like, but you have to tell me whether it is a function, yes or no. You can use the vertical line test if you like.